College Prep Chemistry. So we are continuing on with our first unit on the foundations of chemistry, and we're dealing with math topics that are used in chemistry. So what is a logarithm? First of all, logarithms are somewhat intimidating to students because they don't know what they are really. They don't really understand what they're used for. So I'll just make the point that you don't have to be an expert at logarithms to the extent that we use them in chemistry, but you should understand what they are and why they're used, and that will help you in your math classes as well. So a logarithm is an exponent. An exponential function is a function with the x independent variable in the exponent. So logarithms are the inverse functions of exponential functions. So here's an exponential form of a basic logarithmic function. 10 to the x equals y. So 10 raised to some exponent x will give you some number y. We could just plug in a 2, for example. 10 to the second power will give you 100. Now in logarithmic form, it's log of base 10 of y equals x. So let's go ahead and take that example. So example, 10 to the second power equals 100. And then in log form, it's log of base 10, 100 equals 2. In other words, in the logarithmic form, it's saying what is the exponent that you need to raise 10 to get 100. And you need to raise 10 to the second power to get 100. So that's log form. So ultimately what you get out of log form is the exponent that's required to raise the base to get the final answer. So the parts of a log are the base. That's called the argument. We don't use that term in this class very much, if at all. And that's the exponent. So log A means log base 10a. So if no base is shown, then the base is assumed to be 10. In other words, you don't need to write log and then a small 10. If you just write log, it implies base 10. However, there are other bases that you can use. There's only one other that we will use in this class. But if there's no base written, then the base is assumed to be 10. Natural logs. Now a special base that appears in nature is 1/8. The letter E represents this number. It's called Euler's number. So E equals 2.718. So E is not a variable. It's just a symbol for that very specific number. And it is an irrational number that goes on forever, but we usually just chop it off after about 3 digits or so. A special symbol for logs with a base of E is ln, natural log. So the log of base E to the x is the same as saying natural log of x. So you don't need to write log base E, you just write ln, which is natural log of x. Inverse functions are functions that reverse each other. For example, addition and subtraction are inverse functions. Square and square root are inverse functions. So if I took the number 4 and added 6 to it, that's an addition. That gets you to 10. If you then take 10 and subtract 6 from it, it gets you back to where you started at 4. So the plus and the minus reversed each other. So that's what an inverse function is. Exponential and log functions are inverse functions of each other. So here's another example. If you take 2 and raise 10 to the second power, you get 100. If you then take the log base 10 of 100, it gets you back to 2. So the exponential, which is 10 to the second power, and the log will reverse each other. The reason this is significant, this principle, is that it's necessary to solve some problems that we will do in chemistry. You don't really have to have a deep understanding of logs, you just have to understand a few principles and know where to plug in the numbers. So you start with 2, raise the base to this power, then take the log of the result and it returns you to 2. So they inversed each other. So here are some log properties. The first one, that if you have a base, a to the x, times the same base, a to the y, it's the same as that base, a to the x plus y. If you have a log of a times b, two numbers multiplied together, it's the same as the log of a plus the log of b. If you have a raised to the x power and then you take that and raise it to the y power, it's the same as a to the x times y power. If you have the log of two numbers being divided, a divided by b, so the log of a divided by b, that's equal to log of a minus log of b. Base a to the x over base a to the y equals a to the x minus y. We saw that when we did scientific notation, that you subtract the exponents. Log of base x to the y equals log of base b to the y, log of base b to the x. This is called the change of base formula. We won't use it in this class, but it's one of the best properties because it means you can take a log of any base and change it to a base of your choosing, which is always going to be base 10, and then you can solve a log in any base. But we won't use that in chemistry. Okay. A raised to the negative x power is the same as 1 over a to the x power, so it flips it. It's the reciprocal of that number. Log of a raised to the x power, this is an important property here. If you have log of a raised to the x power, you can take that exponent and put it out in front of the log term, so it becomes x log a. And the last are the inverse properties here. So 10 raised to the log of x equals x. E raised to the natural log of x equals x. So they inverse each other. And over here, same thing. Log of 10 raised to the x equals x. And natural log of e to the x is x. So they inverse each other as well. So example, find the value of x in the following equation. So 4 raised to the 2 plus x equals 3.2. So you've got an x up there in the exponent. So how do you get that out of there and solve for x? So take the log of both sides. So you take the log of 4 raised to the 2 plus x, and over on the right side, you take the log of 3.2. Anything you do to one side is legal as long as you do the same thing to the other side. So using rule number 8, you can move the 2 plus x term in front of the log. So it's 2 plus x times log 4 equals log of 3.2. Now you can find the log of 4 and the log of 3.2 using your calculator. So it's 2 plus x times 0.602, that's the log of 4, equals 0.505, that's the log of 3.2. And you solve for x by dividing both sides by 6.2 and subtracting 2. So divide both sides by 6.2, subtract 2, you'll get x by itself, and that will be negative 1.16. Example, find the value of x in the following equation. So again, we're going to use the inverse properties. Those are properties 9 and 10 on that chart that I just showed you. So raise e to the ln 2x on the left side and e to the 3.2 on the right side. So you take both of those, you just turn those both into the exponents of e in both cases. Okay, using rule 9, this creates an inverse on the left. So e raised to the ln 2x is simply going to be 2x. And e raised to the 3.2 power, you simply do that on your calculator, and we'll show you how to do that, and that's going to be 24.5. Now you divide both sides by 2, and that gives you x equals 12.25. So let's talk about what do logs do in general. This will help you maybe in math class to understand them a little better. Logarithms serve two main functions in science. They linearize, that is, make a straight line out of curved exponential functions so that analysis becomes possible. They scale down outputs of an exponential function to make graphing possible. So let's take the most basic exponential function, y equals 10 to the x. So your exponent is the variable. That's the definition of an exponential. The variable is in the exponent, so y equals 10 to the x. So let's say you take 6 values of x, 0 through 5. and you plug them in for x there. You'll end up with y values ranging from 1 to 100,000. Well, that's going to do two things. It's going to produce a curved line, but you can also see that just trying to graph that table right there, if you tried to graph x against y, it's almost impossible, because you start with 1 and you go all the way up to 100,000. And that's a huge range of numbers for your output. Now, if you graph y equals log of 10 to the x, then that's going to be an inverse function. Then simply for every x you put in, you're going to get the same value of y out. 0 produces 0, 1 produces 1, 2 produces 2, and so on. Okay, so you can see it's easier to graph the table on the right than the one on the left, because the range of numbers for y only goes from 0 to 5. It's much easier to graph. Let's look at it graphically now. So the graph y equals 10 to the x, if we plot an exponential, the graph will increase so quickly that it will not fit on a piece of graph paper. So you see that's a curve as well. It's curved and it goes up very quickly. It also produces a curved line. If you extend this graph to x equals 10, the red line, if your computer screen is the same size as mine, the red line would reach beyond the moon. It's hard to believe that, but it would. It would go up that quickly by the time you got to y equals x equals 10 to the 10th power. Now, if you graph y equals log of 10 to the x, plotting x against the log produces a number that can easily fit on a piece of graph paper. It also linearizes, creates a straight line of the data. So unlike the graph on the left, this graph can easily display all the way up to x equals 10. And you know how to find the slope of a line. You learned that in Math 1, so you know how to do that. So you can more easily analyze this line, analyze a straight line. Analyzing a curved line requires calculus. So this is a much easier line to find the slope, the y-intercept, things that you've learned to do in math up until now. All right, and that takes care of this quick lesson on logs. Don't worry, we're not going to get too deeply in it. I'm just presenting it now because this first week is on the math topics that relate to chemistry. We'll get to this in a few topics later on in the course.